Greetings everyone. Today we're going to explore solving compound inequalities, specifically compound inequalities that are OR inequalities. So for a moment, let's talk about that word OR. Pretend you're standing in the middle of the room. You can go left or you can go right. So if you think about the directions you can go when you use the word OR, that's going to help translate onto a number line. We're going to have a graph going left, and we're going to have a graph going right. We do have a note sheet for this. It would make it a lot easier for your notes, so make sure you have access to that. Let's start off with example 1. Example 1, we want to graph on a number line all real numbers that are less than 0, or, there's our break, or greater than or equal to 6. Now I'm going to start by writing this as an inequality. All real numbers, that's an X. Let me color code that actually. All real numbers, X, that are less than 0, 0. Or all real numbers, I'm going to repeat myself because that's what that sentence means, all real numbers that are greater than or equal to 6. Now on a number line, here's what this is going to look like. We need a 0, we need a 6. So I'm going to go 0, 3, 6. If you're creating your own, you can choose your jumps, right? If I'm less than 6, that means I'm going to be open and I'm going to go left. Remember, if you need help graphing, you want to see previous videos. Or I'm going to be greater than or equal to, which means solid dot going right. Now keep in mind, if it has the word or, they're going to go apart. No overlapping, no togetherness, this way or that way. So just imagine you're standing in the middle. You can go left or right. Let's take a look at another example. This time we're given the inequalities. We're dealing with the numbers -5 and 2. It's or equals to at -5, so that means a solid dot, and it's less than, so that means left. Or x is greater than or equal to, that's a solid dot because it's or equals to, and greater than means right. Here's the thing, if it says or, you're going to go left or right. All of our graphs for or will look this way. Let's take a look at this one. This time we actually have a little bit of solving to do, right? I need to get the letter by itself. Instead of +7, let's -7. We want to undo it. 0 minus 7 is -7. Let's solve the other one while we're here. Instead of t minus 2, let's plus 2. The t falls down. 5 plus 2 is +7. So on my number line, I have -7 and +7. So let's take a look at this first one. Notice the word or, right? So I can already assume they're going to go opposite this way or that way. What I need to work on is the symbol. At -7, we're or equals to, which means shaded in solid, go left. On the second inequality, it's just greater than. That's an open circle, and it says greater, so we're going right. So when you think of these OR inequalities, just think, it's two separate problems. One goes left, one goes right. If one doesn't go left and one doesn't go right, something's wrong. Okay, all the ORs will go left and right. Ooh, we got more solving to do here, okay? Got a little bit of work to do. Let's start off with this left one. I need to kick this 5 over first instead of -5 plus 5. Gets me to 8. Then that divide 2's in the way. See how that big fraction bar is in the way? So instead of divide 2, let's times 2. That gets rid of that, right? Then it's not in the way anymore. 8 times 2 is 16. instead of instead of plus 2, minus 2 gets us to 14, and divide both sides by 7. So far I have y is greater than 2. Let's solve the other one. That big fraction bar is in the way. Instead of divide 4, let's times 4. That gets me to 8. I need to add or subtract next. This is a positive 4, so I'm going to have minus 4. Be careful with that. That's a negative 2y that falls down. Then I divide by a negative 2. Whoa, 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 what did I just divide by? I just divided by a negative. So I need to flip the sign. That rule still applies. So my other inequality is y is less than negative 2. So come time for the number line. At negative 2, we're open. At positive 2, we're open. And here's the thing, you guys. You can actually assume if it says or, one's going left, one's going right. They don't overlap, they don't cross. All right, so I tried to throw an example of each type of or inequality. Here's the thing, like even stick your thumbs up in the air and remember that the graphs need to go opposite every single time. The only thing you have to really think about is open or close, to be honest, but it always goes left or right. Make sure you check Google Classroom to see what our task is for today. Let me know if you have any questions, and until next time, have a good one.